Hi class, it's Mrs. Kane and I'm back with your next lesson. My kids are jamming out in the basement right now to Backstreet Boys, so hopefully they won't be too loud. I can hear the music, but hopefully it's not going to cause any distraction here. All right, so today we're going to talk about properties of logs, and specifically there's 3 properties we're going to talk about, and we're going to use the properties to expand logarithms. So to introduce the properties, we're going to do a quick little exploration. As we go through this exploration, it will also review how to evaluate logarithms, which is what I talked about in yesterday's video. All right, so for our first problem, it says evaluate each logarithmic expression. And the first thing we're asked to evaluate is log base 2 of 4 plus log base 2 of 8. Okay, so remember that logs equal exponents. So if you want to figure out log base 2 of 4, you're trying to figure out 2 to what power equals 4. Okay, and for log base 2 of 8, we want to know 2 to what power equals 8. Okay, so we know that 2 squared equals 4 and 2 to the third equals 8. And so this is 2 and this equals 3. And so the answer is 2 plus 3, which equals 5. Okay, so we just evaluated each log individually and then we added the expressions. For part B, it says find log base 2 of 4 times 8. Okay, well we know that 4 times 8 is 32. So I'm going to start by saying this is log base 2 of 32. Okay, so if we rewrite that, log base 2 of 32 is really what we're trying to find here. Okay, so 2 to what power equals 32? Okay, we've seen this one quite a few times in this unit. Okay, you can use guess and check in a calculator if you have to. I think most of you can recognize that 2 to the 5th equals 32. And so the first expression equals 5, and we just found that this expression also equals 5. Okay, and so it says, what do you notice? Okay, so what I want you to notice, it might not be glaringly obvious, but if we look at our original expressions, okay, they are equal to each other. So log base 2 of 4 plus log base 2 of 8 is equal to log base 2 of 4 times 8. Okay, and so this is a property that we're going to talk about today. It's called the product property. So it allows us to do 2 things. We can take the left side of this expression and we can condense it to one single log. Okay, so log base 2 of 4 plus log base 2 of 8 is the same as log base 2 of 4 times 8. So we can take these 2 log expressions and write them as a single log. Okay, and then another thing that we can do is we can expand this logarithmic expression. So if we start with a single log that has a multiplication in the argument, we can pull that multiplication apart and expand the logarithm, and that's what we're going to talk about today. Okay, so I'm going to actually zoom down to the bottom here to the properties of logs, and we're going to fill in the first property called the product property. Okay, the product property says if you have log base b of a times c, in the case we just did, we had 4 times 8, okay, we can pull those apart. We can write log base b of a plus log base b of c. Okay, and when we pull those apart, we're doing what's called expanding. We're going to expand this single log into 2 logs. Okay? All right, let's talk about another property. So the next problem says evaluate each logarithmic equation. Okay, right off the bat, I notice I have a typo here. This should say log 3 of 81 over 9. So if you can fix that real quick. Sorry about that. Okay, so number 2, we're going to start by finding log base 3 of 81 minus log base 3 of 9. Okay, so similar to how we started the first one, we're going to find 3 to what power equals 81. And then we're going to do 3 to what power equals 9. Okay, so 3 to the 4th is 81. If you didn't know that off the top of your head, use a calculator. And we know 3 squared is 9. Okay, and so this equals 4 minus 2, and so the answer is 2. Okay, 4 minus 2 is 2. For part B, it should say log base 3, not base 2. So log base 3 of 81 over 9. Okay, so I know 81 divided by 9 is 9. So I'm going to start by saying log base 3 of 9. Okay, and so now 3 to what power equals 9? Well, 3 squared equals 9. And so log base 3 of 81 over 9 also equals 2. Okay, so if I erase my little notations here, if I look at the original expressions, what I want you to notice here is that log base 3 of 81 minus log base 3 of 9 is equal to log base 3 of 81 divided by 9. So it's very similar to the product property, but this is called the quotient property. Okay, so we're going to learn how to take two logarithmic terms and condense them. Okay, that's going to be tomorrow's lesson. And we're also going to talk about how can we take one logarithmic expression and expand it. Okay, and that's what we're going to talk about today. So this is an illustration of what we call the quotient property. Okay, if you have log base b of a quotient a over c, we can expand that and write log base b of a minus log base b of c. And when we take one single log and we pull them apart and write two logs, that's called expanding. All right, and then the last property we're going to talk about is going to be the power property. So it says log base 2 of 4 squared. All right, well, we know 4 squared is 16. So to make this easier, I'm going to say log base 2 of 16. And so 2 to what power equals 16? Well, we know 2 to the 4th is 16. And so this original expression equals 4. Okay, log base 2 of 16 is 4. All right, and part B, it says, what is 2 times log base 2 of 4? Okay, well, let's figure out what is log base 2 of 4. So 2 to what power equals 4? Well, 2 squared is 4. And so this expression equals 2. And so now we have to do 2 times 2. And our answer is also 4. Okay, so the last thing I want you to notice, and again, I'm just trying to introduce these properties. So if I look at part A and I look at part B, I take away my notations. What I want you to see and notice is that log base 2 of 4 squared is equal to 2 times log base 2 of 4. And so what happens here is that exponent 2 came out in front of the log. Okay, so if I took that 2 and put it out in front, I would get the right side. Okay, so this is an example of what's called the power property. So let's go down and fill that one in. So it says if you have log base b of a to the c power, you can take that exponent and you can put it out in front of the log expression. Okay, and when we put that exponent out in front, we are expanding our logarithmic expression. All right, so we use these properties above to expand and condense logarithmic expressions. And again, today's lesson is going to focus on expanding, and tomorrow we'll talk about condensing. All right, so if we scroll down, I rewrote the product, quotient, and power properties so that you have them in front of you as we go through some examples. So the goal of expanding log expressions is to rewrite the expression using as many logarithms as possible. So we're going to start with an example where we're going to use each of the properties just once, okay? So write each expression in expanded form. So if you have log base 3 of 5 times x, we are going to use the product property. We're multiplying 5 times x. And so this property says that we can write log base 3 of 5 plus log base 3 of x. So we simply pull apart the factors, 5 and x, and we give them each their own log. And we separate that by addition. Okay, so the next example, log base 7 of 6 over y. So this one, we're going to take a look at the quotient property. And we're just going to pull the top and the bottom apart using subtraction. So log base 7 of 6 minus log base 7 of y. So each term gets its own log. Notice the base stays the same. Make sure you write that base of 7. Okay, and then the last one we're going to take a look at in the application or an example of the power property. Log of x squared. Now there's no base written, so we assume the base is 10. So when we expand this, we also don't have to write our base. So all we have to do here is we have to take this exponent 2 and we need to put it in the front. So 2 times log of x. Okay, so those are just basic examples using each of those properties. So now we're going to bump it up a level, and in the last set of examples, we're either going to be using more than one property, we're going to have more than 2 terms, or we're going to have to change a radical expression into one with an exponent. So the first problem, we have log base 2 of the cubed root of x. Now we don't have a property for radicals, but we do have a property for exponents. And so what we're going to do here is we're going to start by rewriting the cubed root of x as x to the 1/3 power. So we have log base 2 of x to the 1/3 power. And the reason I'm going to write it that way is because now I can use the power property and I can put that 1/3 out in front. Okay, and that's it. The next example, we've got 3 terms. We've got a 4, an x squared, and a y. So that means that when we pull this apart, we need to use log base 7 3 times. Okay, the 4 gets its own log. I'm going to separate the 4 and the x squared using addition. So log base 7 of x squared, that gets its own log. The y is on the bottom, so that gets subtracted. So minus log base 7 of y. And then the last step here is we got to take that 2 and we have to put it in front. We're trying to make it as long as possible. And so we get log base 7 of 4 plus 2 times log base 7 of x minus log base 7 of y. Okay, and once you do enough of these, you'll end up just pulling that exponent out in front right away. Okay, you won't have to do it in 2 steps. All right, so the next one, log base 4 of 3 times the square root of a. So similar to the first problem we did in example 2, we're going to rewrite the square root of a as an exponent. Okay, so I'm going to start by rewriting this problem as log base 4 of 3a to the 1/2 power. Okay, so now I have a product, so I'm going to pull these apart. I'm going to give the 3 its own log. I'm going to separate the logs with addition. And I'm going to give the a to the 1/2 its own log. And then lastly, when we're expanding, we always want to put the exponents out in front. And so we get log base 4 of 3 plus 1/2 times log base 4 of a. Okay. And then the last example, log of x cubed divided by 5y. All right, so what I want you to notice here, we're going to start, we need 3 logs, so log of x cubed. Now, we're dividing by a product. So I want you to put minus, and then we're actually going to put this product in parentheses. We're going to pull apart the 5 and the y using addition. Log 5 plus log y. Okay, so notice now we're taking the x, so this tells me the x cubed is in the numerator, and then 5y is in the denominator. We're dividing by that product. Okay, so to simplify this completely, I'm going to put the 3 in front, and then I'm also going to go ahead and distribute my minus sign. Okay, so the final answer for this one is going to be 3 times log x minus log 5 minus log y. Okay, and notice the only thing on top is the x cubed, and then the minus log 5 means the 5 is on the bottom of the fraction. The minus log y means the y is also on the bottom of the fraction. So anything in the bottom, in the denominator, should have a minus sign in front of it. All right, so hopefully that made some sense to you. I want you to go ahead and do the daily practice assignment so you can get a little bit of practice expanding logarithms. Thanks for watching, and I'll talk to you tomorrow. Or I guess I will talk, yes, at you tomorrow with another video.